Okay. So, right. So this vectors question says portion vector of the points R, S, and T are given by these things. Those are the three position vectors. All right. So this one is OR. This one is OR. This one will be OS. This one will be OT. Right. So that's what is given. All right. So let's write them down over here. So this call it OR is the vector minus 3, 4. OS is the vector 1, 1. And OT is the vector 5, negative 2. 5, negative 2. If there's some talking in the background, it's because I'm still at work, right? I'm just going to try to find a quiet place, but hard to find a quiet place here at work. All right, so those are the three vectors. First part wants us to find this thing, which is the modulus of OR. That's the length of the vector OR, or the size of the vector, modulus. All right, so let's do that part one. And the modulus of OR will be equal to the square root of the negative 3 squared plus the 4 squared. And that's going to work out to 5 units. Or I get 5. That's a 3, 4, 5 triangle. Those will be the size of a 3, 4, 5 triangle. Or we can say the 3 squared is 9, the 4 squared is 16, the 9 and the 16 is 25, and so the square root of the 25 is the 5. All right, so that's how we get that. So that answer is 5. Now let me just explain to you why it becomes the length of it. Now the vector OR, what the vector OR being 3, negative 5 means, OR is a vector. Or negative 3, 4, sorry, negative 3, 4. It means to go from O to R is somewhere down here. You go 3 units this way. Let's draw that better. You go 3 units to the left. That's negative 3. And 4 units. No, 4 units up. So I draw it the wrong way. So it's back and up. So O is here. O is here. And R is somewhere up here. So negative 3, 4 means you go 3 units to go from O to R, you go 3 units back. That's negative 3. And then 4 units up. So the negative 3 this way and 4 units up this way. All right. And then the vector OR now is this straight vector across here. All right. And that is the vector OR. That is the vector OR. And it is the length of this line that I want. And if you use Pythagoras' theorem, you see that it becomes the square root of the negative 3 squared plus the 4 squared. And in fact, you don't have to put the negative here because it could have worked out that triangle. This length is 3 and this length is 4. And so the hypotenuse using Pythagoras' theorem will be the square root of 3 squared plus 4 squared. So oftentimes you don't have to put the negative when you find the modulus, because it's going to come out positive anyway. All right, so that's how we get the length of that vector. All right, so let's move on to the next part. So the next part now says is this, part 2. Expressed in the form xy, the vector rs and the vector xt. Those are 2 displacement vectors. So part 2. First, they want the vector rs. And what we did, we came up with a simple formula for rs in class. Displacement vector is O times the last minus O times the first. Last minus the first. So the vector is rs. R is the first, s is the last. And the displacement vector rs is O times the last minus O times the first. So it is os minus or. That's a simple way to write a displacement vector. O times the last minus O times the first. And OS is this one. All right, and so it is 1, 1, minus OR, which is negative 3, 4. And then we have to care for the negative right here. Because remember, negative is a plus. So it really becomes 1 plus 3, which is 4. And 1 minus 4, which is negative 3. 1 minus 4, which is negative 3. So that's the vector RS. And then we want the vector ST. So this is RS. Then we want the vector ST. So we can say and the vector ST. Similarly, with the O times the last, which is OT, minus O times the first, which is OS. O times the last minus O times the first. The OT is 5, negative 2. That's from up here. The OT is 5, negative 2. Minus the OS is still 1, 1. And then it becomes 5 minus 1 is 4. And minus 2 and minus 1 is 3. So that these are the same. When two are the same, they are equal and parallel, equal in length and parallel. So those are equal vectors. They don't have to be positioned in the same place, but they are equal vectors. All right. And part 3 now says, using the results of combining the vectors in V2, these are two vectors I want us to combine now. Justify that RS is parallel to ST and that RST is a straight line. So basically RST is a collinear, right? Straight line means collinear. So what we're basically saying is that the RS from up there, the RS vector is equal to the ST vector. All right, so these two vectors are equal and so they are also parallel. That's what's happening here. Firstly, they are parallel. So 1, they are parallel vectors. So parallel. And then secondly, you have a common point. Right? Common point on this vector is S and a common point on that vector is S. And so we have a second thing happening here, which is called a second condition. So the second thing that is happening is that S is a common point. And when you have parallel vectors with a common point, because of these two, because of the theta, you have those two conjugates and the T, the points involved, are collinear. So we can say, therefore, R, S, and T, RS and T are collinear. Some people spell collinear with 1 L, sometimes can spell it 2 L, depending on whether it's an English spelling or American spelling. Collinear simply means that they are on a straight line. They are on a straight line. Which is what we are told to show over here. Show that they're on a straight line. All right, this guy that completes that question. All right, so there are any questions, remember, just chime in right away or wait till I finish and gone. That is that question. All right, so let's save that and go on to the next question. All right, so next question. No. The next question we have is, where is it? This one. All right, so we're doing this one now. All right, let's put on the markers again. All right, so this question now gives us this diagram here. And it says in the diagram below, coordinates of P and Q are 2, 4, and 8, 2 respectively. And those are shown here and here. So that is on the diagram. All right. And so the line segment joining the origin O to the points P may be written OP. So what they're basically saying is that this line may be written OP with arrow on top. Let's write that clearly. This can be written as OP with the arrow on top. And the first part says we have to write the term for that vector OP, right? What term is used to describe that vector OP? Now, any displacement vector from the origin to a point, any vector from the origin to a point is called a displacement vector. So this one is the displacement vector of P, not displacement vector, position vector, sorry. Any vector from the origin to a point is called a position vector. So the vector from the origin to P is a position vector of P, and the vector from the origin to Q is a position vector of Q. All right, and that is what they are called, position vectors. So OP is a position vector of P. So let's write that over here, part 1. OP is the position vector of P. Similarly, OQ will be the position vector of Q. That's a displacement vector from the origin of the point. The vector from an origin to a point is called a position vector. And then the vector that will take you straight from P to Q now, like that vector across here, that will be the vector PQ. That one is called a displacement vector. The vector between 2 points is called a displacement vector. All right, so if you ever ask you that, that is what you'll have to say. Once it's coming from the origin, it is a position vector. If it is between 2 points, it's called a displacement vector. All right, this right here should have been OQ. This question right here, part B, should have been OQ. All right, so let's answer part 2 though. So part 2 now wants first the vector OP. This is the position vector of P. And OP will basically have the same coordinates, same values as the point P. Vector OP will have the same values as the point P there. And so OP is simply, don't need no calculation for that. It's simply 2, 4. You don't need no calculation for the position vector if you know the coordinates. The coordinates and the position vector will have the same values. And then we need the vector OQ, right? So part B wants a vector OQ. And so since Q has coordinates 8, 2, then the position vector of Q will also have the values 8, 2 in a column vector format. And so it is 8, 2. What does that mean? This one, the 2, 4 means that to go from O to P, you go 2 units this way and 4 units up. That's what it means, you know. 2 units this way, 4 units up. It's just like translation, right? And then now the other one for OQ, what does it mean? What does this one mean? 8, 2. OQ is 8, 2. It means that to go from O to Q, you go 8 units to the right. That's 8 units to the right this way, and 2 units up. That's what the 8, 2 mean. All right, and that's the same values that you will use for the coordinates anyway. So that's why the same values in the space, in the position vector. Same values. All right, so basically that's that. Let's look now at the third thing, which is PQ. See, PQ. So calculating PQ similar to how we did the previous question, PQ. Once you want to find a displacement vector, you know the position vector of the 2 points, you know the position vector of P, you also know the position vector of Q, then you can use the same thing I just did a while ago. O times the last minus O times the first. So this vector PQ is equal to OQ minus OP. O times the last minus O times the first. The OQ is 8, 2 minus the OP is 2, 4. And so that works down to 6, negative 2. 6, negative 2 is a vector PQ. Right, and remember now, when you're doing on vectors, anything you get by calculation must match the diagram. So let's show you what this means on the diagram. It means to go from P to Q, you'll go 6 units to the right and 2 units downwards. So this will be 6 units this way, and then 2 units down to get 2 units down to get that vector from P to Q. That's what this means. 6 units to the right, 2 units downwards. All right. So the diagram is showing that because from 2 to 8, you got 6 units, and from 4 down to 2, you go down 2 units. So everything you have in the calculation is matching what the diagram is saying. When you're doing vectors questions with a diagram, you should get in the habit of matching everything that you are saying. Everything that diagram shows must match what you get by calculation. All right. Then we'll come down to this part now. This part now says they want us to back to here. Let me start. So down here now, we want to cancel. We want to know they tell us that OP is equal to RQ now. I want to determine the coordinates of R. So R is a point that they introducing now. All right, so let's use a vectors method to do that. So part 3, they tell us that OP, vector OP is equal to the vector RQ. Remember that the vector OP is 2, 4 now. This is vector 2, 4. Right? So it's almost like we're really solving this side now. This is PQ. This is OP, sorry, this is OP. I want to find the vector OR from this. So this is like we have a vector equation now. And in this vector equation, we know what OQ is, but we don't know what OR is. And so we can basically split this side of the vector equation to find the OR that we want. All right, so let's split it. Let's go ahead and show how you split it. Split it up into position vector. So I want to split this vector, split this. I want to split this side into position vector. So it becomes OQ minus OR. O times the last minus O times the first, which then is equal to 2, 4 on the right side. And we're trying to make OR the subject, right? So we can carry over the OR over this side and make it positive, and then carry the 2, 4 over this side and subtract it. All right, so let's do that. So the OR on this side becomes equal to the OQ minus the OR, minus the 2, 4, sorry. All right, so that's it. So this come over this side and become positive, and this come over this side and become negative. Transposing, I want to make OR the subject. And then the OQ that we have right here is the same OQ that is really just equal to 8, 2. Right? And so we can do the calculation. And so OR, let's go back for that. And so the OR is therefore equal to 8 minus 2 right there, which is 6. And 2 minus 4 is negative 2. So OR is 2, negative 2. OR is 2, negative 2, i.e. the vector OR is 6, negative 2. All right. So if OR is 6, negative 2, it also therefore means that the point R, no, this is our answer, you know, that's what I wanted to know. That is the answer, you know. But just to emphasize something to you, if the position vector of R is 6, negative 2, then it means that the coordinates of R will have the same value as 6, negative 2. 6, negative 2. All right. So it's 6, negative 2. That's correct. Let's see if that's correct. All right. times OPQR. That's what it says next. It says justify that the quadrilateral formed by, state the type of quadrilateral formed by PQRO. PQRO. All right, so the 6, -2, if you put on the sketch, right, the 6, -2 is somewhere down here. 6, -2 will be somewhere down here. That's where R would be. All right, and the quadrilateral we're talking about now is this quadrilateral. So to sketch it on the diagram. This point will be 6, -2. Right? And they want us to tell them what kind of quadrilateral that is. It looks like a parallelogram. But to confirm it's a parallelogram, we have to show that this vector equals this vector, and that this vector PQ equals this vector OR. So let's confirm that, right? Now let's look back at what the PQ was on the top. See it here? The PQ is right here. 6, -2. Right? So we can say part 4 we're looking at now. So we're saying the PQ side is equal right now to the OR side, which is 6, -2. And then we also have to show now that the other two sides now, this side and this side, are also equal and parallel. I think they actually gave us that one. God gave us that right here. There. Right. They told us that the OQ was equal to the OR, right? And the OQ, no, so we're not proving it yet, right? We're not proving it yet. No, they didn't give us that. We have to show that one. We need to show that these two sides now. Now we'll do that a while ago. The PQ equals a OR. So we do that one already. We really need to show these two now, which is the OP and the RQ. Show that the OP and the RQ equal. So we didn't calculate RQ. So that's what we need to do to complete the statement, right? So we're doing these two sides. We'll mark them again and leave it for the time being so we don't get mixed up. All right, so we're doing the OP and the Q and the RQ. So we have to calculate RQ. So we can say no, because we don't have it yet, you know. RQ would be equal to, but they gave it to us here. See here, so we'll have to calculate again. They told us already. So wasting time. That was given. So that's right. So we can say something like, and given that OP is equal to RQ, which worked out to be 2, 4, we have what we have. We have 2 pairs of equal opposite parallel sides in the quadrilateral in quadrilateral PQRO, which is therefore a parallelogram. It's a parallelogram because it has 2 pairs of equal opposite parallel sides. All right, that's it. And I'm basically sketched on the diagram, and you can see it right there on the diagram as well. All right, so that is that. All right, so let's save this and go back to a blank page so we can do the next question. All right, let's erase everything from this. And then go back to the next question. Which is now this one. All right, so about this question now. Now that question, the diagram question, all right? Now what we're gonna do is put information on the diagram as we get it. So when I get the information, I put on the diagram. Well, this question is gonna depend on the diagram now for the information. All right, but let's read and see that anything that they state in the information, you need to put it on the diagram. So you don't have to go reading to find the information. So it says in the diagram below, not drawn to scale, B is the midpoint of OX. So this point B is the midpoint of OX. I mean that this length and this length is the same. All right, and since it's vectors we're doing, right, it means that whatever vector this little piece is, this vector is the same vector. Because the length of this piece is the same as the length of this piece. And then they are the same direction this way. And so those two will be equal, right? So we establish that information. That is the midpoint right there. It also says that C is the midpoint of AB. So again, C is the midpoint on this side. Therefore, AC and CB are equal. Right, and then we can also say AC is half of AB, stuff like that. All right. There's also a midpoint formula for the position vector of the midpoint. We can look at that afterwards. Treat the midpoint as an average point. So basically, the position vector OC, let's just write it, will be equal to half of the OA plus the OB, like an average point. That's like how you find midpoint at that point with average points. The position vector, which is this vector now, OC, will be equal to this, half of OA plus OB. When we will find out what those are. All right, so I'm just giving that information in case we need it. All right, so let's go again. Then I gave us some ratio on the line. It says D is such that D, which is this D, is such that OD is 2DA. OD is 2DA. Now, what I always tell the student to do is write the information on the line. So they're basically saying that this OD right here is 2DA, and DA itself is 1DA. So if you subtract the DAs, you say that the line is 2 to 1. So the line is 2 to 1. It means that this piece is 1/3 of the whole line OA. And this piece is 2/3 of the whole line OA. Because the line is in the ratio 2 to 1 based on that information. Let me do that again and show you so you can see it. The information said that OD is 2 times DA. So I'm putting the 2DA on the OD part, 2DA. Right, put it on it. 2DA. All right, and then I put the 1DA on this. And then I erase the DAs. Erase the DAs. So I'm left with the 2 to 1. So I know that the line has 3 parts. 2 parts down here and 1 part up here for a total of 3 parts. And then down here now is 2/3 of the whole line, and up here is 1/3 of the whole line. Right, and that will help us to find some partial fractions, some parts of the vectors, some fractions of the vectors. You see here now, they're telling us now that the vectors A and B are such that the whole of this vector up here, so let me give you a convenient value now, is 3A. So the whole vector is 3A. That means that right here is 2/3 of 3A, which is 2A. And right here is A. Remember, everything must have 3A now. Right? And then the vector B right here now is B. So that is B. Then this vector also is B. All right, so let's put on all the information that we can on the diagram. The more information we have on the diagram, the better. All right, so let's clean it up and then put on all information based on what they have said. So based on what we have deduced, because this side is 2 to 1, it means that this is 2a. This vector is 2a. This vector here is a, such that the whole thing is 3a. And then this vector right here is b. And because this is the midpoint, it means that this vector also is b. So that OX is actually equal to 2b. All right, OX is 2b. We can also see that OD is 2a. All right, OD is 2a. So that information, the more position vectors you know, the better. All right, so we have those, can work with it for one. But let's answer the question now. We can just use a diagram to get these. Right? Since we can work with the diagram. So the first part, let's do it over here now. Wants us to find the vector AB. So if we want, we can use O times the last minus O times the first, you know, OB minus OA, which would therefore just be B minus A. Because this is B and this is A. No lie, B minus 3A, my bad. B minus 3A. 3A. Because this is 3A. All right. Or we could look at the diagram and say, okay, how do we go from A to B? We can go 3 this way, 3A this way, which is really minus 3A because you're going in the opposite direction to A. So that's minus 3A plus B. Right? So we can look at it that way. So if we're doing it that way, we can say, or looking at it the other way, AB is equal to A to O, and then plus in vectors means and then going O to B, and the A to O will be minus 3A. Okay, going in the opposite direction to OA, going in the opposite direction to OA, so it's minus plus B, which basically is the same as this, same as B minus 3A. All right, so I can do it by calculation, I can do it using the diagram. All right, either way, same answer. All right, so the next part now they want is AC. AC. Remember that AC is just half of AB, you know. So that's fairly straightforward. All right, so for part B now, this is a vector AB equals this. So part 2 now, part B now, we want the vector AC. And based on the diagram, AC is just half of AB. So it's just half of this, half of AB right there. So AC becomes half B minus 3 over 2A. Okay, you half this and you half that. And so you get this. And you half them. All right, so that basically is your AC. And the next part now wants DC. DC. So we can use the diagram or we can use calculation. Let's use the diagram. Since the diagram is there, let's use the diagram. So part C now wants us to do the vector DC. The vector DC. Look at the diagram. How can we go from D to C? We can go D to A and then A to C. That's what we can do, you know. So it's DA plus AC. So let's use that. So the AC is equal to D to A, and then plus means and then A to C. When doing vectors, plus means and then. And the DA clearly is A, plus the AC is the same AC that this is coming back here, same AC. So it is half B minus 3 over 2A. All right. All right, that has one vector with a 1B term and 1A term. So we're going to put this is the only B term in it. So we're going to write about that first. So it's half B. and then a whole A minus 3 over 2A equals what? It equals minus half A, but let's look how we can get it to minus half A. What we can do to do calculation quickly is to write this A as 2 over 2A, so that it has the same denominator as that. And when they have the same denominator, we can just focus on subtracting the numerator values, which will be 2 minus 3. Right? So that in any case, anyway, we want to look at it, going to give us minus 1 over 2A. That is a vector DC right there. So DC equals that. That's the vector DC. And the next part now wants dx. I want dx now. So look at the diagram again. I want to go from D to X. We can go D to O and then go from O straight across to X. And so you come down here and go straight across here. That's the easy way to do it. Or we can use these two vectors. Since we know those two vectors, we can do both on the last one as both on the first. All right. Anyway, you want to look at it, you're going to get the same result. There is a calculation, I use a diagram. So part D, you can do it two ways. You can say we're trying to find dx. Using the diagram, it is do and then O to X. The do is minus 2A and the OX is 2B, which basically becomes 2B minus 2A. All right? Or we could say dx, because we know the position vectors here, over here, we know the two position vectors. We can say dx equals O times the last, which is OX, minus O times the first, which is OD. So this guy get the same result, because the OX is 2B, minus the OD is 2A. So you get the same answer, whichever way you choose to do it. That is dx. And I'm going to do it both ways in the exam. I'm going to do it one way. Right? Do it one way in the exam. All right. So the next part now says state two geometric relations between dx and dc. So part 2, we are comparing dx, which is 2b minus 2a, and dc, and dc equals what? Let's look at dc. dc is half b. Space is out too much. Let's look a little closer. Right, let's put this a little closer. Right, so comparing dx, which is 2b minus 2a, and dc, which is dc up here again, is half b minus half a. Half b minus half a. I want to compare them. Now, usually, when you're doing vectors at this level and they ask for a relationship between lines, the relationship is that they are parallel. That is one of the relationships we have to show it. And the other relationship now, it can be expressed in terms of how long one is more than the next one, relationship of the length of the two vectors. All right. So to show on the diagram what we're comparing dc and dx. Here, dc with dx. So we can draw it. dc dx with that straight line there. So comparing this piece with the whole piece. And then I can say that DC, they're on the same straight line, and so they're parallel. It's on the same straight line, they're parallel. And then because one point is a common point, whether the D is a common point, C is a common point, the D or the X is a common point. If you look at the equation form, the D is a common point because dx has D in it and dc also has D in it. All right, so that is what happens. But to do the comparison, see how long one is more than the next. The procedure is get rid of any fractions first. Why? Because the fraction makes it harder for you to see the relationship between them. So any fractions you have in the vectors, you want to get rid of the fractions first. So this is the one with the fractions. To get the fractions out of that one, we multiply by 2. We realize that if we multiply by 4, it actually gonna come equal to this one. So it makes sense to just multiply by 4 and done. So we're going to multiply this one by 4. That will get rid of the fraction and also bring it equal to this one. So multiplying it by 4 times this one by 4. So we times it by 4. We get 4dc equals 2b minus 2a. And now they are equal because this equal 2b minus 2a and this equal 2b minus 2a. So it means that this vector must equal this vector. That's what happens. All right. So we can write that. So we can say therefore. Dx is equal to 4 dc. Alright, so when you have that, it means that the vectors are parallel. When one vectors are multiple, the next one, it means that the vectors are parallel. So it's a must state 2 geometric relationships, right? After 2 lines. So that's what we're doing for part 2. So the first geometric relationship is that they are parallel. Dx is parallel to dc. That's one. The second one is in relation to the length. How long one is more than the next. You can see it on the diagram. dc is 4 times the length of dx. Dx is 4 times the length of dc. Hold on a second, please. All right. Dx equals 4 times the length of dc. So you can write that. Dx is 4 times the length VNGTH of dc. That's what this equation is saying. All right, dx is 4 times the length of dc. Because the vector is 4 times as long, then the length is also 4 times as long. All right, and then now part 3 says we are to state one geometric relationship between the points. One geometric relationship. That's what the third part down here is saying. State one geometric relationship between the points. All right. And when you ask for a geometric relationship between points at this level in vectors, it is that the points are collinear, but you still have to show it, tell the reasons, right? Show the reasons. So let's go back to the equation. We have dx equals 4 times dc. And there are 2 things that must happen for you to have collinear points on a straight line. And the 2 things are happening here. The first thing is that they must be parallel, which we have already. Dx is parallel to dc. That's the first condition you need to have collinear points. The second thing that must happen for you to have collinear points is that there must be a common point. What you normally do on the exam is underline the common points. And you state it. D is a common point. And once you have those 2 conditions, it means that the points involved are collinear. So you can write it. Therefore, Therefore, D, C, and X are collinear, meaning the points are on a straight line. Right? That's what collinear means. 3 points are on a straight line. And you can see it on the diagram. You can see it on the diagram over here. So what we did in the calculation, we are basically getting on the diagram. All right. Basically, that was the last question. State the geometric relationship. State one geometric relationship between the 3 points, B, C, and X. That one geometric relationship is that the points are collinear, but you still have to show it. Not just state it, show it. All right. So basically, that is that. All right. So that completes the vectors question that we wanted to do. So let's save this and go back. So let's clear this off. I'm gonna go back now to that paper that I sent you. All right, so the paper that I sent you now. So many people have. We have 14 persons, no problem. So all right, so the paper that I sent you was this paper. All right, so let me see if we can do the paper this way. All right, so yeah. All right, so starting right here now, this paper. So the question said, first question on this paper said, the information below represents the minimum temperatures in degrees Celsius recorded in a country A or in country A for the first 20 days of a particular month. Right, so basically these are those temperatures. All right. And if you notice, they are not in ascending order. So this is data as it was collected. Remember, generally speaking, you want to put the data in ascending order. You can choose to put the data in ascending order and list them and do the statistics of raw data. But if you note, they are put it in a table and they are putting it as an ungrouped data frequency distribution table, ungrouped data. All right, and that's because I feel like there are too many terms, there are 20 values here. So they decide to put it in a table more than leave the data in the raw state to analyze it. All right. So anyway, they say complete the frequency table below using information above. So first, they want us to complete the tally column and also the frequency column. Now the tally column is basically just you adding up the values, and then the frequency column now is the total of the tally. So they've started it for us. So they've completed the 21s. So let's mark off what they have done. So they've completed the 21. So it's 121. They've also done the 22. It's only 122. All right. So let's do the 23 now. So I want to do is mark each one different. So we can go back and check if we make a mistake. Our finish is supposed to have 20 values. So that's the tally for the 23s. Or we can do is just count them and just put in tally marks for the 23s. So let's count the 23s. I'm going to underline them this time. So it's 1, 2, 3, 4, 5. 5 of them. So I'm going to put the tally mark for 5, which is this. 1, 2, 3, 4, 5. That's the tally mark for 5. The next one we need to check are the 25s. 25s. I'm going to do the 25. I'm going to tick the 25s. So we have 1 here. 2, 3, 4, 5, 6, 7, 8. 8 of them. So I'm just going to put in the tally mark for 8, which is 1, 2, 3, 4, cross for the 5, and then 3 more. 1, 2, 3. That's the tally mark for 8. By the way, I need to fill out the frequency column. So I need a 5 here, and I need an 8 here. And then for 26, let's put an X on the 26. How many 26? And this is what we have so far. Everything was up to 20 to 20. We put an X on the 26 marks now. So I have just one 26 mark that is there. It's one. Let's check. Also 1 here. 1, 2. So total mark for 2 is that, which is 2. And then you check it up, right? So this and this is 10. And this is 10. 10 and 10, 20. So you know that, all right, you covered everybody. So everything is good. All right, so you don't have to double check anything. Everything add up to 10. So that is good. So that's the first part. Second part now says we have to determine the median. Right? Now, there are 20 values. And since there are an even number of values, the median is going to mean that you have to add one value between the two middle values, which is the average of the two middle values. But how do you find the two middle values? If you want, you can list the values, the 20 values. Right? So you can, for example, put on the 21 first, and put on the 22, and put on the 5 23s. You see, it's too much work, that, right? You don't want to do that, because that's a waste of time. I like you don't know your maths and you do that. Right? So instead of listing them down like that, what you can do is basically count how many terms you have by putting in a cumulative frequency column, where you're adding up the frequency to count how many terms you have as you go down the values. All right? So after you put in the 1, you will have 1 term. After you put in the 22, you now have 2 terms in the line. You put in the 5 23s, you now have 8 terms in the line. You put in the 3 more terms, you now have 11. Now have 11 in the line. And then you put in 8 more terms, you have, that's right, somewhere around. Oh, this is supposed to be 7, made a mistake. 2 and 5 is 7, right? So this is supposed to be 7. Let me not shortcut it so don't make a mistake. Right, so put in 1 value first, and then it's 1 plus 1 more equals 2. Then it's 2 plus 5 more equals 8 values. Then it's 8, no, equals 7 value, right? 8 again, imagine that. Equals 7 values. Then 7 plus 3 will now have 10 values. Then 10 plus 8 will now have 18 values. And then 18 plus the last 2 values will now have 20 values in the line. All right, so we can basically count how many values we have as we go from value to value, counting how many values we have. All right, now when the data is ungrouped like this, all right, then the position, the median is Q2, you know, remember the median is Q2. The position of the median, which is Q2, is half of the n plus 1 term. Half of the n plus 1 term, n plus 1 term. That becomes half, that's not the median, it's the position of it, you know. That's half of the 20 plus 1, which is half of 21, which is the 10.5 term. So if it's a 10.5 term, it means that it's a term between the 10th and the 11th term. All right, so look here now. This is the 10th term here. When we finish putting these values, we reach a 10th term. That's a 10th term. And the 11th term is going to be somewhere here. One of these values is going to be the 11th term. So the 10th term, this is the 10th term. And this is an 11th term. This is a 10th term. These are the positions, you know. Remember, these are the positions. These are the positions. So the 10th term is at 24, and the 11th term is at 25. And therefore, Q2 equal the average of those two values. Right? The average, that's what 10.5 means. The term between the 10th term and the 11th term. All right? Which is the average of those two, the 10th term and the 11th term. Oh Lord, sorry. Right, so it becomes the 10th term is 24 plus 25. Those are the two terms, 24 plus 25 over 2, which works out simply to 24.5 degrees Celsius. So remember, the temperature is in degrees Celsius. All right. So that's how we get 24 plus 10.5. Well, I can't avoid the noise around me, so let's excuse the noise, please. I can't avoid it at all. All right. So basically, that's that. Any questions, let me know. So moving up to the next part now. Next part now says we have to calculate the mean. So to calculate the mean, if you like, you can just add up all. Yeah? Yeah? Yes? Go ahead with the question. Hello? Somebody have a question? What have a question?
Answer.
Huh? Somebody have a question or not?
No, sir.
All right, cool. All right, so back to this now. All right, so what I was saying, if you like to find the mean, you could just add up all these values, add them up, and divide by 20, right? Or you can do a mark of the paper. So let me take these off back. Let me take this off. I might need a sum column. You can put in a sum column right here beside this. Put in a sum column. My sum column is f times x. This is the f frequency. These are your scores, which is x. That's a quick way to add them up, right? So remember, you're multiplying the frequency and the scores. So it will be 1. It will be 1 times 21 is 21. 1 times 22 is 22. Then 5 times 23 is how much? That's 115. Somebody can check that for me. 115. 115. And then 3 times 24 is 72. And then I'm doing the wrong thing now. Yeah, frequency, right? And then 8 times 25 is 200. Yeah. And then 2 times 26 is 52. And then you sum all of these to get the sum of fx, sum of all the values. So you add up everything there. All right, so it will be 21 plus 22 plus 115 plus 72 plus 252, which will be 482. Will be a sum of all the values. And so you can write it now. The mean is the sum of all the values, sum of fx divided by the number of values. Number of values is the sum of the frequency, which is 20. So it will be 482 divided by 20. All right, which basically becomes 200, becomes 24.1. 24.1 degrees Celsius. The mean is the mean. The mean will be equal to that. And that's an accurate value because the data is not grouped. We don't know the actual values. We know the actual values. Right? And basically that's it. 24.1 degrees Celsius is the mean. Any questions there? All right, everybody good. Let's move on. Next question. All right, so the next question is this. This is a question similar to something we have done already in the class about some pizza business. All right. Question says, the diagram below represents a cross-section of two circular pizzas, A and B. Pizza are similar but vary in size. Pizza A has a diameter of 15 centimeters. So pizza A has a diameter of 15 centimeters. Let's see if we can mark it. Let's mark it in purple. So this is 15 centimeters across here. And this one is 30 centimeters across here. It's a diameter. They didn't give us the radius, they gave us a diameter. We can still work with the diameter, right? And so clearly this one is twice this one, right? One of them is twice. Clearly to go from this one to this one, you multiply by 2. So like an enlargement of scale factor k equals 2. Can you look at it that way too, you know? Everything in maths valid, you know? So we can look at it as an enlargement of scale factor 2 because the sides dimension is now doubled. The dimension in terms of length is now doubled. All right. So the question says, determine by calculation if beta B is twice the size of beta A. You cannot go and use one dimension to measure relative size. You have to use area to measure relative size. You're not measuring the length of one thing versus the length of something, but the cross section is the same, right? Or the width is the same, right? This thing is a circular, and so you cannot just use one dimension across. You have to use area. So to compare them, you have to use area, all right? Now, because enlargement, because you can look at it as an enlargement of scale factor 2, you don't have to actually calculate the area to know, you know, it's going to be such that, remember, treat this as if it is the image and this is the object, right? And enlargement of scale factor 2, watch this now. Using enlargement, the area of B equals k squared, scale factor squared, treating this as a scale factor. Enlargement of scale factor 2, scale factor. Right? K squared times the area of the object, which is B, which is A. And so the area of B becomes 2 squared times the area of A. And so the area of B is 4 times the area of A. So therefore the area, therefore beta B is 4 times the size of beta A. All right, that B is 4 times the size of A, not twice as the axiom. It's not twice, it's actually 4 times. But we could actually calculate it. So we can use our method. I think this will be easier if you recognize that you can use enlargement. We could actually calculate it using area. Now let's write the formula for area over here. This is a different color when you have the diameter. Area is pi d squared over 4 when you know the diameter. All right, that's the formula for area. You know the diameter. All right, so let's look at it this way then. Area A will become pi times 15 squared over 4. And somebody can write that out for me. And area B will be pi times 30 squared over 4. Right? You can write that out. Squared equals. So somebody write them out for me, please. Let me the area of A and area of B. Anybody? Nobody?
Sir, for
Yeah.
area.
For A, it's 176.7.
176.7 centimeters squared. And the other one going to be 4 times that, I bet you. The other one going to be 4 times that.
225.
How much?
225. Wait, no.
No.
706.9.
Oh, you forgot me. Alright, so one is 706.9 or 0.8.
It was 0.85,
Depends
so I put time for 0.9.
And this, alright, so let's put that 0.9. I'm gonna put that 0.8 because actually it's 4. If it's 0.8, it's 4 times.
Okay.
And it is supposed to be 4 times. Because you're off the round of the values, that's why, right? That's what happens. Yeah. Alright, so. Alright, so 0.8 centimeters squared. So you see that the area B is 4 times. So if you divide them, area B over area A, it becomes 706.8 over 176.7, which is 4. So you see therefore that area B is 4 times area A. We didn't have to go through all of that, and you come back to the same conclusion that I had up here. Same as up here. Right? Same thing you put back down here now. Same conclusion. Alright? And though we show it is actually 4 times because it's like an enlargement of scale factor 2. And when it comes to area, remember the relationship is area of image is k squared times area of object. Alright? So basically that's that. Next page. So the next page now tells us that the pizza B is cut into 5 equal slices and is sold for $6.95 per slice. All right. And then pizza A is sold as a whole for $9.95. Determine which of the 2 options, slice of B or the pizza A, is the better buy. Now the better buy is one that you're getting more for your dollar. All right, so let's look at the information. We're gonna look at pizza B. All right, pizza now. Hold on a sec, please. Hello, I'm in a class now. I call you back, please. I'm in a class. All right. All right, so this is pizza A and pizza B. Pizza A, pizza B. I'm going to compare which one is the better buy. So it's area of compare now. What area of pizza we're getting for our money when we buy it, right? So what did they say? They said pizza A is sold as it is. So we're going to compare the 2 areas. So let's look back at the area of pizza A. Now pizza A area was 176.7. All right. So pizza A is 176.7 centimeters squared for how much money? $9.95. And pizza B, now they divide pizza B by 5. So pizza B, they divide the area by 5. Right? And that area was 706.8 centimeters squared divided by 5. Now divided by 5, which was equal to what? So divide that here by 5. And that is 141.36 centimeters squared. So it's 141.36 centimeters squared. That is sold for $6.95. So if you want to know which one is a better buy, you need to see how much pizza you're getting for your $1 in this one, how much pizza you're getting for $1 in this one. So you need to compare. The one that you're getting more of for $1 is the better buy. All right, so that's how you know what the better buy. So let's see what we have to do. To bring this side down to $1, we need to divide this ratio by that value of 9.95. So divide both sides of the ratio by 9.95. So I'm going to divide this by 9.95, and the money part will come down to 1. And so it is 176.7 divided by 9.95. So basically it comes down to 17.76 centimeters squared for $1. So every $1 of pizza in this one, every $1 you get this amount in that pizza of every $1. Let's look at this one now. For this one, I'm going to divide by the $6.95. Right? Divide the ratio by 6.95. So the dollar come down to 1. The money part come down to 1. So I'm going to divide by 6.95 so that the dollar part come down to 1. You want to see how much you get in for your $1. So it's 141.36 divided by 6.95, and I'm getting on this one, I'm getting 20.34 centimeters squared to the dollar. So therefore, this one is the better buy. Better buy. I get in more pizza for $1 as compared to this one. All right, so it's better to buy one slice of pizza B. Better buy is one slice of pizza B. All right, you're getting more for your $1 if you buy one slice of the B pizza. All right, getting more pizza for your $1. But understand that. All right, good. 5 now. All right, this one says, in a football tournament, points are awarded as follows: 3 points for a win, 1 point for a draw, 0 points for a loss. Everybody know that's what goes in football. It says write a 3-by-1 matrix. Now remember, 3-by-1 matrix means 3 rows, 1 column. 3 rows, 1 column. So it means that that matrix is P equals the 3, the 1, and the 0. So P is points. P represents points. Points you will get for a win and a draw and a loss. So this is for a win, this is for a draw, this is for a loss. That matrix is a points matrix. All right. Next part says, during a tournament, Team Alpha, which you can call Team A, recorded 5 wins, 1 draw, 3 losses, while Team Beta, which you call Team B, recorded 3 wins, 4 draws, and 2 losses. It says write a 2-by-3 matrix R for this information. R means results. So we need 2 rows. Let's mark it out. Remember, the 2-by-3 means 2 rows, 3 columns. So we need 2 rows, 3 columns. 2 rows, 3 columns. That's what we need in this matrix. All right, I'm putting in the values. So what is going to be is that the row first row is going to be for A. This one is going to be for B. This one is going to be for the wins, the draw, and the losses. That's how the matrix is going to go. All right, because it's 2 teams, so it's 2 rows, 3 results, so those are your columns. So that is a result matrix. So your result matrix is going to be 2 rows, 3 columns. This row is for A, this row is for B. This is for your wins, this is for your draw, this is for your loss. All right, so it's going to be 5, 1, 3 for A, and 3, 4, 2 for B. All right, that's it. That's R, that's the result. So that's a points matrix up here. That's a results matrix down there. All right, concentrate when you're doing these things. Don't just write. Make sure everything makes sense. All right, and this one, I'm gonna put back like a sketch right here. So this was a 3 by 1 matrix. All right, this for the win, the draw, and the loss. That was it. 3 by 1 matrix. 3 rows, 1 column. All right, down here now, it says calculate the matrix product, RP. So they want us to multiply R by P. Now, note that we could not have done P times R. Remember, in order for you to multiply matrices, the number of columns in the first matrix must match the number of rows in the second matrix. So it had to be R times P. It could not be P times R. So anyway, let's do it. R times P equals the 5, 1, 3, 3, 4, 2 matrix times the column matrix, which was a points matrix, which is 3, 1, 0. That's for multiplying, right? This is going to give you what kind of matrix you're going to get for that. Let's work out what kind of matrix you're going to get for it and show you what the resulting matrix size is going to be. Now remember that we're multiplying a 2 by 3 matrix. I'm multiplying that by a 3 by 1 matrix. Now this matrix multiplication is possible because the number of columns in the first matrix match the number of rows in the second matrix. That means that it is possible. And then the resulting matrix is going to have this number of rows with this number of columns. So the resulting matrix is going to be a 2 by 1 matrix, which is just a column matrix. Two rows, 1 column. All right, that's what you're going to get. 2 rows, 1 column. All right, this basically would be the points, just the points that the teams get. All right, so let's show you. It's gonna be 2 rows. This is by the purple. It's gonna be 2 rows, 1 column. So those are the values it's supposed to get. So let's work them out now. Now, how we work out these matrices now? Remember, when you multiply matrices, you multiply the rows of the first matrix. Rows of the first matrix times 1 column. And multiply along the row down the column. All right, so let's work out the first one here and show you what's going to happen. First value there. All right, so along the row down the column. So it's 5 times 3 is 15. 1 times 1 is 1. And 3 times 0 is 0. That's the first value. And then for the second value, it is 3 times 3 is 9, 4 times 1 is 4, and 2 times 0 is 0. All right, and so the final result is 16, 13, 16, 13. And that's the results for A. So that's the results for A. So it means that A, the A team, alpha, got 16 points. And beta has 13 points. That's what that matrix represents. The points that they get. Can you see? You multiply the wins by 3. They multiply the draw by 1. They multiply the losses by 0 to get the scores for A. And these are the scores for B. Right? Then now, same thing here. You multiply the wins by 3 to get the 9. Then you multiply the draws by 1 to get the 4 points here. And then multiply the 2 losses by 0 points to get the 0 here. Right? That's it. So that's what it means. The next part now says, what does the product PR represent? It basically represents the points that the teams got. And so represent the points obtained by the teams. Or the points for the teams. It represent the points scored. Or the points total for the teams. That's what it represents. Points total. Points total for the teams. Represent the points total for the teams. That's what it is. All right. Good. Next part. All right. The next part now gives us this information right here. It says the values recorded in the table below represent the velocity of an object over a period of time. So it's a velocity time graph. All right. It says on the grid below is a graph. 2 points are plotted. So 2 of the points are plotted already. And they want us to plot the remaining points on the grid. Now remember, always read the scale of a graph before you start to work. Don't just start working, read the scale first. Right? So this one is 1 per unit, right? So this is 1 centimeter per mark, or what? 1 per mark. 1 per mark. All right? And down here now, you got 10 before you reach 5. So it's half per mark, basically. And this will be 1, then 2, 3, 4, 5, right? So it is half per mark. So down here is half per mark. Half per mark on the horizontal axis. Always work out the scale first. Don't just start working. All right. So always work out the scale first. So let's look which points I put in already. I put in the point where the time is 5. So it's this one. And also put in the point where, remember this is 15, 16, 17, 18. So 18. So they put in the one where the time is 18, which is this one. And so those 2 gone in already. So we have the other 2 to put in now. All right. So The one that we're putting in knows when the time is 12 and the velocity is 34. Time is 12. So this is 10. Let's zoom it up so you can see it. All right, so this is 10, 11, 12. So right here is 12. And going up to 34. So come up on this line right here. So 30 here, so. And every line is 1. So the right here is 34. So put that X right here. So right here, so it's 34. 12, 34 that. All right. And then the next one is 25 times 60 velocity. So it's 25 here. It's 25 right down here. I'm going up to 60. So that is right there. That point. All right, so we see everything line up perfectly on a straight line. So clearly they're going to want us to draw that graph, right? So it's a plot the remaining 2 points on the grid and draw best line, best fit line. All right, so we have to draw that line. See if we can draw it as straight as I can. So that line looks like that. All right. This guy, that's that. Good. So that's a line. So part finish. Clear the line passes through 10. You can see that. Passes through 10 on here. Crosses the axis at 10. Alright, in case I need that. That will be the speed when the time is 0. If they ask that. Let's see what they ask though. Alright, so on the next page. It says, given that the linear motion, because we get a straight line, the linear motion of the object can be expressed in the form V equals, so the teller says V equals AT plus U. So this is just like saying Y equals MX plus C, you know, because on the graph that we have over here, the Y axis is V, yeah. So the Y axis is a V, and the time axis, horizontal axis is a T. And get a straight line graph. So if you get a straight line graph, instead of a Y and a X, you know, have a V and a T right here. Have a V and a T. So it therefore means that from this, the A equals the gradient of the line. Because the A is like a M, and the U is like a C. The U is like a C, and so the U is the, and that y-axis intercept is the v-axis intercept. It's a v-axis intercept, just like a y-axis intercept. So instead of using y equals mx plus c, we're now using v equals at plus u. So it's just similar, they're very similar. Instead of having a y-axis, we have a v-axis. And instead of having a x-axis, we have a t-axis. Write these as common letters. As they're supposed to be y equals mx plus c. All right, so the a is like our gradient and the u is like our y-axis intercept. All right, and it says where a and u are constant. So use the graph to determine the value of a and u. So let's go back over the graph now. So remember the u is a y-axis intercept like the c. This is like the c, and this is like the m gradient, right? So let's go back over there now. So looking at the graph now. So the C clearly is right here. This is the y-axis intercept. C, which is the U, which is 10. So we know that one already by observation. All right, and the next thing we need is a gradient. All we can do simply is use the gradient as a rise over run from this point up to this point. Right? You cannot use rise over run from those 2 points, you know. That will have a positive gradient. So let's look at what the rise is. We'll mark it over different. Let's mark this over this side instead. So this is basically the C value. So this is saying the U is just like the C value. So the U equals 10. And then we're going to use those 2 points for the gradient and measure the rise over the run. So from here to here, the run is across here. So straight, we can draw that. The run is across here to there. And the rise is up here to there. So we can just use rise over run to get the gradient between those 2 points. Easy. Alright, so the run is from 0 to 25. So the run is 25. So the run equals 25. Alright. And the rise is from 10 up to 60. So the rise equals 50. From 10 to 60 is 50. Therefore, can I work it out inside here and show it? The A is just like a gradient M. So the A is just like a gradient, which is rise over run. And so the A is basically 50 over 25, which is 2. Just like this, let me come back, you know, which is 2. All right, I have to give the correct units. It's going to be 2 meters per second squared. All right, I'm going to go over on the next page and show you why that is so. So I agree that the rise is 50 meters per second. This is 50 meters per second. And the run is 25 seconds. All right, I will give the correct unit for the thing. And the 10 is meters per second. All right, so let's go back over onto here. Show the correct thing. So based on what we just said, the U is just a y-axis intercept of 10 meters per second. And the A is the rise over the run, which is a gradient, which is the 50 meters per second over the run, which is 25 seconds. So that becomes 2 meters per second squared. This second times this second on here gives the second squared. All right, and basically that's it. That completes that paper. That's the end of this lesson for today. Anybody have any question? Very good.
Yes.
13 students. Can never get a good class. Can never get a good number of persons. Tired na middle day.
School just done, sir.
So middle day, sir.
Anyway, I've video it, so I'll send the video. Stopping it now, actually, so you guys can watch the video.